Okay, let's get started. Now, as far as the correct way to do that quiz, that's mostly going to be what class is about today, because we're going to be taking that core and we're going to be building off of it. So I'm just going to ask you to hold on just a few short minutes, and I'll be doing that over again. So, but that doesn't mean you can't ask questions. Quiz questions. Let's start with that, because I still have to do some more of what I was starting to do yesterday. Oh, your quiz? Sorry, it's right here. Yeah. I haven't sent a grade report out in a while, so I'm going to guess maybe today I'll probably send another one out, and you'll see some of these multiple quiz grades appearing. Yeah, some of you are probably wondering about that. I'll get that out right away. Okay, now the first thing I want to show you today is, I told you I've been recording classes. I'm trying this just as an experiment, and you can, I think, my whole idea was you can benefit from this. And just let me show you. First of all, let me explain to you. After I get it recorded, it takes about 2 hours to process the video and compress it. Otherwise, it's just massive. Okay. So I use this software, it compresses it, and then I'm posting it for the moment on my WLC, and I'm going to show you how to access it. At the moment, I have Trig 1, Trig 2, and Trig 3 up. Trig 4 from last time, I haven't quite finished processing it. Okay, here's what happens when you go to the my WLC. I've added a button called Class Multimedia down here on the left. When you click on that, it just got two things. I've got class audio and class video. The audio is an MP3 file, and if you wanted, you could download it and put it on something that listens to MP3s if you want. And the video, you can download it. And again, I'll just show you one of each. Okay, like here's the video from Trig 1, or at least I'm not going to look at the whole thing, but we just want to show you part of it. Of course, it all depends on how you have your browser set for playing files like that, and these are big, so you do have to be a little bit patient. Okay, before we get started on our trigonometry study, yeah, I'm not a professional. I'm not walking around with a mic. I've just got a mic sitting right here. So sometimes when I'm over there, it gets a little quieter like this. But if you just keep the volume control handy, you can compensate for a lot of it. I'll just let this run for a few minutes. Right now I'm not doing anything on the screen, so if you're wondering why isn't anything happening. Yes. I'm asking for questions on the last graphing problem. Last graphing thing. Okay, we're going to take a look at number 33 on 4-2. At least, yeah, to see how far we can get into this. So, okay, basically it's a problem of, see if you can graph this thing. X squared minus 5x minus 3. And that's all over x cubed minus 2x squared. Okay, I don't know what's happening right now. Minus x plus 2. And the directions are identify all the intercepts, find any vertical and horizontal asymptotes, check for symmetry. That's me trying to get back into this. Try to sketch the graph of this. Okay. Well, let's do what? Let's see if we can at least approach the asymptote question. If we're going to have a vertical asymptote, it would be because something in the denominator could be 0, right? Well, we can't tell by looking at this. At least I can't. Although, now, it's acting kind of strange because I'm recording right now also. So I'm recording and playing, and it's like, okay, excuse that. So let me just get out of that. Let me show you an audio. The audio, just to show you something different, here's Trig 3.
Was that assignment that you were just talking about? That wasn't Trig, that was like...
No, but on Trig 1, what do? We do a review of... You know how I always begin with questions on the previous lesson? So what you were looking at is questions on 4.2, which was right before we did Trig 1. So in other words, my classes, they work just like, you know, I guess I won't show you the audio, but I guess I will. No, we don't need to do that. But I obviously shouldn't be doing a playback while I'm doing a recording. So I think that's why it's bogged. Okay. So we need to continue. First of all, review our basic famous angles, 30, 45, and 60. So I've got a chart set up for us to review and expand. The red rectangle indicates the section that was on the quiz last time and is the foundation for us expanding the chart today. Our two special triangles are at the bottom of the page. You should see that the one on the right is the isosceles right triangle, where the two acute angles are 45 degrees. Therefore, the two sides opposite the two equal base angles must be equal. The simplest way to do that is call them both 1. And then using the Pythagorean theorem, we could easily arrive at the hypotenuse of that triangle being the square root of 2. Our other famous triangle has a 30 and 60 degree, that's supposed to be 60 degree angles. And the famous geometry theorem there is the side opposite the 30 degree angle is half of the hypotenuse. The easiest way to illustrate that is to call the side opposite the 30 degree angle 1 and the hypotenuse 2. Using the Pythagorean theorem, we could easily determine that the missing leg has the length square root 3. Okay, now using that, we should be able to come up here and fill in our chart. I guess we should do our angles first. And we're to convert each of these degrees into radians. 0 is, of course, 0. And hopefully you remember 30 degrees is pi over 6. If you cannot remember these first three, what you can, or the first 5, the way I've got them set up here, you can remember that each 15 degree angle segment is what? Pi over 12. And 30 degrees is 2 of those. So 2 pi over 12 is 1 pi over 6. And then 3 pi over 12 is the same as pi over 4. 4 pi over 12 is pi over 3. And then 6 pi over 12 is pi over 2, and so forth. Then you can do some other things, like 120 degrees is double 60. Well, if 60 is pi over 3, then 120 must be 2 pi over 3. 135 degrees is a 45 degree angle past 90. So it's like a half a pi plus a fourth of a pi, which is 3/4 pi. 150, well, let's do this. 180 is pi, and 360 is 2 pi. I ran out of room for my chart, so you notice my last two angles are down below here. So if 180 is pi, and 150 is just 30 degrees short of that, that means 150 is 1/6 pi short of a whole pi. So in other words, it's 5/6 pi. 210 is a pi over 6 past pi, so 1 1/6 pi. 225 is back to our 45 degree angle past 180, so that would be 1/4 pi past 1, 1 1/4 pi. 240 is double 120, so instead of 2 pi over 3, it's 4 pi over 3. 270, pi and a half. 300, which is double 150, 5 pi over 6 doubled would be 10 pi over 6, and simplified, that would be 5 pi over 3. 315 is 45 degrees greater than 270. So 3/2 pi plus a fourth of pi. So 1 1/2 plus a fourth would be 1 3/4. 7 pi over 4. 330 would be what? Pi over 6 short of 2 pi. And 2 pi is what? 12/6 pi. So this would be 11/6 pi. Okay, we got our angles set up now. Now, using our triangles, let's fill in, first of all, the amounts in that relate to those triangles. Sine of 30 degrees, leg opposite over hypotenuse. Excuse me. The sine of 45 degrees. You can use either 45 degree angle. Leg opposite over hypotenuse. Sine of 60 degrees, leg opposite over hypotenuse. Cosine 30, leg adjacent over hypotenuse. Cosine 45, leg adjacent over hypotenuse. Cosine 60, leg adjacent over hypotenuse. Tangent 30, leg opposite over leg adjacent. Tangent 45, leg opposite over leg adjacent. And tangent 60, leg opposite over leg adjacent. Okay, there's our core, and everything's positive in the first quadrant, so we know all the signs are positive here. Now, if you can get that little projector in your mind going, we know that from the behavior charts, the sine, S-I-N-E, this first row, comes from the sine behavior chart, and the sine, remember, relates to the vertical leg in that right triangle that goes around. Just a quick look back here. This vertical leg, this thing right here, is what we want to keep our eye on. Just highlight it here. As the angle goes around, we want to see what happens to the length of that. And I think you can see that at 0 degrees, we're going to be down at 0. So back on our chart here, the sine of 0 is 0. When you get up to 90 degrees, it's going to be full height. All right, now 120 degrees. Here's the way you want to think about this. 120 degrees, always relate back to the x-axis. 120 degrees, what's the closest, how far do you have to go from a 120 degree angle to get to the closest x-axis angle? And the answer is, that would be down to 180, and that's a difference of 60. Okay, so really I'm asking about a 60 degree angle, and the sine of 60 is already on our chart. Then all you need to do, and this is very important, is check on the SIGN. All right, thinking back to the sine chart, what's the SIGN of the sine when you're in the second quadrant? Notice it's positive. That's because we're still above the x-axis. So this truly is a positive. We're correct here. 135 degrees. What angle does that form with the nearest x-axis angle? This time 45 degrees. Okay, what's the sine of 45 degrees? 1 over the square root of 2. 150 degrees is how far from the x-axis? 30 degrees. The sine of 30 degrees is 1/2. And again, the SIGNs with both of these is still, because we're in the second quadrant, we know the SIGN of the SINE is positive, so all three of these have to be positive. All right, back to our behavior chart. What happens at 180 degrees? When you get down to 180 degrees, the sine has returned to 0. So we know this is a 0. Now, third quadrant, 210. How far is that from the x-axis? 30 degrees. All right, what's the sine of 30 degrees? From our red rectangle, it's 1/2. Now, what about the SIGN of the SINE in the third quadrant? Well, the answer is that's below the x-axis, so this has to be negative. Very important that we have that sign correct. 225 degrees is 45 degrees from the x-axis. The sine of 45 from our red square over here is 1 over the square root of 2. Again, the SIGN has to be negative. 240 is 60 degrees away. That's root 3 over 2. Again, because it's in the third quadrant, we're below the SIGN of the SINE is negative. 270, way down here, it's at its full height down of -1. So 300 degrees, that makes what angle with the nearest x-axis? 60. The sine of 60 is the square root of 3 over 2. Now the SIGN of the SINE in the fourth quadrant is, it's negative. So let's see, we don't need that stray mark there. So this has to be a negative here. 315 makes a 45 degree angle. So we know we're at 1 over the square root of 2. Again, we're in the fourth quadrant. The sine, the vertical coordinate is downward, so it's still negative. At 330 degrees, we are 30 degrees away. The sine of 30 is 1/2. But because we're in the fourth quadrant, we got to be negative. 360, we're back to 0. So it's exactly the same as the sine of 0. Okay, so we have our sine run all the way through the 4 quadrants with our special angles. Cosine. So as we look at the cosine behavior chart, we see that at 0, now we're looking at this horizontal coordinate down here, this guy, and we know that that when this angle is depressed all the way down to 0, it's going to be a full width, it's going to be 1. So the cosine of 0 is 1. When we get to 90 degrees, what happens? The cosine, because it's horizontal, shrinks down to nothing. And so the cosine of 90, as you can see, is 0. Of course, when I ask you to do this on a quiz, you're not going to have these behavior charts to refer to. So you really have a lot of work to do to get those those patterns into your head. 120 degrees, we're back to what angle formed with the nearest x-axis? 60. What's the cosine of 60? 1/2. And what's the SIGN of the cosine in the second quadrant? Take a quick peek. Yep, it's negative. So this has to be negative 1/2. 135. What's the angle formed with the nearest x-axis? And the answer is, that's 45 degrees. Cosine of 45 is 1 over the square root of 2. But because we're in the second quadrant, cosine is a horizontal guy. He's to the left and must be negative. 150, closest angle to x-axis, 30. Cosine 30, square root 3 over 2. Cosine in second quadrant, once again, negative. Now when you get all the way to 180 degrees, the cosine is full width left, or negative 1. 210. 30 degrees is the closest angle to the x-axis. Cosine 30, square root 3 over 2. Because we're still to the left of the y-axis, that must be negative. 225 is a 45 degree angle. Once again, get it from our red rectangular area over here. And we know the sign is negative. 240 is 60 degrees away from x-axis. So we're back to 1/2. And because we're to the left of the y-axis, this still has to be negative. At 270, we'll take a peek back here. 270, the cosine has shrunk down to nothing. So we got a 0 here. When we move to 300, we moved to the right of the x-axis, so we know our SRGNs are going to turn positive. 300 makes what angle to the closest x-axis? This time would be 60 degrees. The cosine of 60 is 1/2, and this is positive because we're to the right. 315 is a 45 degree angle, so we know we're at 1 over the square root of 2. And again, positive because we're in the fourth quadrant. 330 makes a 30 degree angle with the x-axis. The cosine of 30 is square root 3 over 2. Fourth quadrant, it is positive. 360, we're back to full width to the right, or a positive 1. Okay, tangent. Tangent, remember now, tangent, we have this new visual where this tangent line off here on the right, this line that only crosses the, it only intersects the circle at one point, that point of tangency right there. It's called a tangent line. And what we want to know is, on that tangent line, where does the hypotenuse intersect it? And then what's the length between there and there? And that's basically representative of what happens to the tangent function. So when we're at 0 degrees, the tangent has been completely depressed down to 0. When we get to 90 degrees, we have a problem. 90 degrees, this hypotenuse will be up here, and this line will never intersect the tangent line. It'll be parallel. And we have our first undefined, I better rewrite that, our first undefined answer for our chart. At 120, nearest x-axis angle, 60. To make it into 180, the tangent of 60 is square root 3. What happens now to the SIGN of the tangent as we sit in the second quadrant? Quick peek. Yeah, it's negative, because when you're over here, the hypotenuse has to be backed up and will meet the tangent line below the x-axis, therefore negative. 135 is a 45 degree angle. Tangent of 45 degrees is 1, and as we just established, the SIGN of the tangent in quadrant 2 has to be negative. 150 is 30 degrees from the x-axis, tangent of 30, and again, because we're in the second quadrant, negative. At 180, we have a complete collapse, and when you back up the hypotenuse, it comes right back to 0. 210, that's a 30-degree angle with the nearest x-axis. The tangent of 30 is 1 over the square root of 3. How about the SIGN? Well, when you're in the third quadrant, you're down here. You back up the hypotenuse, and it falls above the x-axis. So, sure enough, you can see the SIGN of the tangent in the third quadrant is positive. So that's correct. 225 is a 45-degree angle. Again, positive. 240 makes what? 60 degrees with the x-axis. So tangent of 60, again, positive. 270, we've got another one of our parallel undefined. Anytime you reach the y-axis, you're going to have an undefined for tangent. 300 degrees, we're now in the fourth quadrant. We're 60 degrees away from the x-axis, so this is root 3 again. But because it's in the fourth quadrant, meets down below, the sign is negative. 315 is a 45-degree angle, so it's a 1 value-wise, and because it's in the fourth quadrant, negative. 330, 30 degrees away from the nearest x-axis. The tangent of 30 is 1 over the square root of 3. Because it's fourth quadrant, it's negative again. And then finally, we've come full circle. When it comes back to 0 degrees, the tangent will be back to 0. So, this is, hopefully you can see now that if you know this red square, you're going to do pretty well on this if you get your SIGNs right. If you don't know your red square, well, you are in deep trouble because your errors here will be multiplied and you will have a pretty bad virus. Things won't go well. You really need to nail this thing and learn it well.